So now we're going to look at power and how we can calculate it. Power has two different definitions and two different equations depending on what's actually been going on. So firstly, power is the rate at which energy is transferred, and we use this equation. So power is equal to energy over time. Okay. And second, um, we're going to use this. So power is the rate at which work is done. So this is a second definition for power. And for this, we use it power is equal to work done over time. So here, power is in watts. So in both cases, power is in watts. Here, work done is in joules, time is in seconds. Work done and energy transferred are the exact same thing. So work done and energy transferred, they mean the same thing. Work done is a measure of energy transferred when a force is used to move an object by a certain distance. That's when we use that example of power. So for example, in this case, a man is moving the car, so he's using a force over a certain distance. Because remember, work done is equal to force times distance as well. Okay, so that's when you would use that. Okay. Now, secondly, if we were to look at this example, if an electrical plug is transferred from the socket, so if electrical energy was transferred from a plug socket to a phone, we'd refer to that as just energy transferred because there's no force acting. So let's use both those equations. Start off with the first one. So here you need to work out the energy transferred when an iron with a power rating of 2000 is used for 5 minutes. So straight away, because we know the time, and this is to do with an electrical appliance, we're going to use power equals energy over time. And here we're working out the energy transferred. So we need to rearrange it. So here we're going to do energy is equal to power times time. So we're going to first of all, energy is equal to power multiplied by time. Sorry about that. And then we need to convert our time into seconds because right now it's in minutes. So we need to do 5 times 60 to put that in seconds. So our time is going to be 5 times 60 to put 5 minutes into seconds. So that's 300 seconds. And then we're going to do 2000 times by 300 to work out our energy. So 2000 times 300, well, that is 600,000. And the unit for energy transferred is joules. So it's 600,000 joules. Okay, so that is our final answer there. So we're using the rearrangement here. Now look at a few more examples. They're not too hard, but they're a little bit. So again, for this one, we do the exact same thing. So we need to do power equals energy over time. So we'll do 1100 times 180 because 3 times 60 is 180. It's 198,000. And you could put that in kilojoules as well if you want to divide it by 1,000. And the second one, here to push a car down the street, you have to do 6 kilojoules of work over a course of 20 seconds. So how much power were you using? Here we're going to use the other equation. So we're going to use work done over time. And so the work done was 9,000 over 20. And yeah, here you have to put kilojoules into joules. So that's 450 watts. So the units are the same. So that's just a little bit about power, how to calculate it as well. If I go back here, this is energy transferred, this is work done. Work done can also be gotten by doing force times distance. So hopefully that all makes sense, and I'll see you in the next video.